How do mode shapes influence vibration analysis? Imagine watching a guitar string vibrate and seeing it from different shapes at different pitches. These shapes are called mode shapes, and they tell us how structures naturally move when they vibrate. Understanding these shapes is key to analyzing vibrations in mechanical systems. When a structure vibrates, it does so in specific patterns, each linked to a natural frequency. These patterns show which parts move the most and which stay still. By studying mode shapes, engineers can predict how a structure will behave when excited by forces like wind, machinery, or impacts. Mode shapes help break down complex vibrations into simpler parts. Instead of trying to analyze every tiny movement, engineers look at each mode shape separately. This makes it easier to see which parts of a machine or building are most affected. For example, if a bridge vibrates at a certain frequency, the mode shape shows where the stress and deformation are highest. This information is vital for designing safer, more durable structures. Knowing the mode shapes also guides modifications to reduce harmful vibrations. Engineers can add stiffeners, damping materials, or change how parts are mounted based on the shape patterns. For instance, if a certain area shows large movement in a mode shape, they might reinforce that spot. This targeted approach helps prevent damage or failure over time. To find mode shapes, engineers use experimental methods like sensors and shakers to excite the structure and measure responses. They also use computer simulations, especially finite element analysis, to visualize how different parts move during vibration. These visualizations show nodal lines, which are points that stay still, and regions of maximum movement. Seeing these patterns helps engineers decide where to make improvements. Mode shapes also make calculations easier because they are orthogonal, meaning they do not interfere with each other. This allows engineers to analyze each mode independently, simplifying the math involved. It makes predicting how a structure will respond to various forces much more manageable. In short, mode shapes are fundamental to vibration analysis because they reveal how structures behave at each natural frequency. They help break down complex vibrations, identify critical areas, and guide design changes. Whether designing a car engine, a building, or a machine part, understanding mode shapes makes the process more precise and effective. This knowledge helps engineers create safer, more reliable systems that can handle dynamic loads without failing.